Hello everyone, welcome to my channel again. Today I'm going to share with you one of the projects I have done in recent days. Basically, this project was designed to interact with ChatGPT and other large language model to uh, build a project with, first of all, a local database, simplified as several CSV file and PDF to contain the information that is useful in my domain. And then I'm going to build query a query workflow with LM Studio and also the LangChain. However, after interacting with the GPT, it does not understand the structure of LangChain. It actually diverts me to another sort of workflow to make my query work. So although you see the names of different Python file is called LangChain, I leave it as this just to remind me that this is not LangChain, but it can be a good start point to understand how to make your query to the large language model better or more efficient. In the future video, I'm going to focus on the LangChain documentation and to really utilize the LangChain workflow to improve our large language model query and get better results. Okay, or as the famous method, RAG, just to better utilize large language model. So first of all, let's go through this file. Just want to share with you on the left hand side, I have two TXT files. I make a record. The first one is about the key points. I actually made a lot of notes, okay, about the different tests, how I improve each file. If you find it useful, you can check it or pause the video and check it. Yeah. And here, I'm going to focus on the step. The step part, I actually ask a large language model to better interpret my final result of the Python file. So basically, the project starts with first part one. Actually, I created two Python file to get the fine history, which were the history where the GDPR, in the EU region, how the GDPR law was enforced to fine the different corporates. Okay, so there are two information sources. First one, I can go to Google News. Okay, this is a package. I like it very much. Can get the dataset very efficiently. The other one is Wikipedia. In Wikipedia, you can always find some summary, and it is quite useful, more structured data. And the last thing is about the GDPR law. GDPR law PDF is pure text, just the wording of the law. And by running these two Python file, we're going to get these two CSV file. One is called the GDPR Fines Wiki, and the other is called the GDPR Fines. This one is from the Google News. You can modify the code as you want, because now I limit the search result just to make it more efficient. Otherwise, for example, if I want to query like 1,000 entries, it will take a lot of time. But for the Wikipedia page, it's faster. Usually here I have two CSV files with the data that I want to feed into or interact with the large language model. I think is more updated and more focused on the use case that I want to implement. Then about the GDPR law, I actually downloaded the law PDF file and save it here. Right, if you can check it on Google and download it from the GDPR website. It's very easy. So then I go to part two. The original idea, like I said, I wanted to use LangChain to interact with large language model, but I take the shortcut to use the LangChain documentation and my idea. I feed it into large language model. It cannot understand how to use LangChain. So I suppose that either the LangChain methodology is too nuanced to the large language model, um, or the large language model just cannot logically decipher the new methodology in the coding. Okay, like LangChain, the different mechanism to interact with large language model. But I followed it and step by step get the results. You can also check the test versions in the past. I'm going to show you one of the example here. Here. So basically in this page, you can see on the left-hand side is the standard LLM Studio query and response. It's very simple. Just give the prompt to the local large language model and get a response. On the right-hand side, it was a mistake here about the HTML file, but actually the prompt to the system was part of the law, which is more relevant to the to my query, and feed both the relevant law part and my query to the large language model to get a more comprehensive response. Okay, you can see the difference. But I can tell you during different tests, different trial of my code, I fixed a lot of bugs. For example, sometimes if you do not use the efficient query method to link your query to part of the text message, some of the query, some of the matching mechanism will just fetch the first paragraph of the law. It's not going to get the most relevant part. If you are interested, you can check my past record, okay, in the test versions. Otherwise, you can go directly to the final version of LangChain LLM Studio version 5 or version 4. So let's focus on this final version here. Okay, we have the dataset ready, and we have also the PDF of the law ready. So now we're going to go through the project. First of all, importing the different packages just to make sure that your code will run. The first part is to download the PUNKT. It is a data package for tokenization, for sentence splitting. Then my code actually define a simple vector, this class of simple vector. It defines how to store the document embeddings and the text documents. Okay, and especially about this part, about the search, this function of search. One time when I tried the code, I actually ignored some of the variables. So even if the code can run, sometimes if you miss feeding some of the variables to the different function, you can get a result. But it is not a complete circle, complete workflow. So I really recommend you to check that every variable is utilized and to make sure that they are they are working in the workflow correctly. So in the next part, we are going to load the pre-trained, it's called pre-trained universal sentence encoder model, okay, from TensorFlow. Okay, it is also part of the very important part of the code. Then this code defined different functions. For example, you can check it one by one. The embed text function converts list of text chunks into embeddings using this universal sentence encoder. Okay, so basically, yeah, this is I think one of the most important parts of the whole code. Then there is load CSV data. So this load actually all the CSV data to put it in one data frame. It is not a very, I think may not be the best option to put them all together. but I just want to feed as an integral part of the data. Okay. Then I also change the CSV to text because in the model, if you are feeding a data frame to get embedding, okay, it is not working. You need to transfer it to text. Then, okay, this is the load CSV data and also CSV to text. About the CSV to text, really pay attention to the encoding. If you get any error, you see some result are not good, you need to change it. And one thing I want to mention about like here, like load the CSV data, if some of the data type is not recognized by the system or by the code, you need to change it, okay, or to specify it. Then we'll go to the next part about load and extract text. So basically, at first I only have the PDF as text information. I did not have the, I had also the data frame, but eventually if I want to make sure all of them are processed, I should both process the PDF and also the text TXT file. Okay, this is just to make sure that all the files can be passed to this function and the text can be extracted. So this serves as extract the text from the file. The next one is NLTK sentence splitter. It actually splits the text into sentences using the NLTK. Okay, so then it will load and split the text, into sentences. Okay, so all these functions seems so complicated, but eventually I'm going to summarize the whole workflow later so you can have a better understanding of it. So basically each function will quote another function to give a periodical result, a sectional result. So you need to really pay attention. Okay, so basically let me just repeat here. TK sentence splitter is going to return tokenized information, and the load and split text is to split the document text into chunks. Then here, I think here these two functions were only one function because at first I only passed the PDF information to set up the vector store. Okay, it's like a query database. But later, when I realized that the data frame is better to convert to text, then pass to the function to get another vector store, I chose to create two functions just to make sure that I understand I'm doing two conversions from text information to vector store. If you find it too complicated, you can of course change this part as long as it matches your user case and make your code better. For me, I just keep it like this. So basically, the most important part is that for after converting the text information to vector store, okay, it will return this vector store as a result. Then there is the function to define a generate response function. Actually, this one is the interaction with the local large language model. It follows the pattern of LLM Studio. First of all, I want to say the reason I set the input variables as two vector store is to just to make my workflow clear so I understand there are two vector stores utilized. So my query will match, first of all, the PDF of the law, the information, then it will match the data frame I provided, but not directly. They are going to check on the vector store. Okay. So this query embedding is going to, first of all, transfer my query to embedding, then find the similar documentation from the respective vector store to find the most similar information from the two vector stores. And eventually the prompt will combine these two and with my query. Okay, so this will be the formal prompt to the local large language model. Here, I want to emphasize the interaction with LM Studio is nice, is local, is safe. Okay, at least for now, I think it's safe. But now I do not see a very comprehensive tutorial on the internet to let you know how to avoid different mistakes, how to debug everything. So you need to try. One of the way is to actually focus on the completion, this client chat completion, and create a function. Okay, you need to check here. This is a documentation of the explanation. You can copy this part to your local file so you can check it quickly. This is a very comprehensive explanation. From here, I actually debugged several things. For example, I set the presence penalty and the frequency penalty to avoid that in the end. For example, if I have a max token of 3000, the system will generate some random code or repetitive code tokens after 500 tokens. So that is not what I want. That is very messy and not beautiful. So here, as you see in the document, I actually used both the frequency penalty and the presence penalty, these two penalties, as the max value of 2 to avoid the system generate the error code as repetitive nonsense characters. I think both penalties work similar. But just to avoid the error I saw, I just put both of them as maximum 2.0. Okay, so like the frequency penalty, it will penalize new tokens based on their existing frequency in the text file, and the presence penalty will penalize new tokens based on whether they appear in the text file. I think their functions are very similar. Of course, you can try different variations. At this moment, I put all of them at maximum value. Also, I checked some of the Google. I searched in Google how to debug this issue of repetitive characters that makes no sense in the LM Studio when we query a large language model. Some people say that we may change the temperature because your temperature is too low. It will limit the performance, and for example, my use case, I would like my result very precise. I don't want to get more creative output because I am analyzing a lot of GDPR. I want to get the relevant output as a report that I care about. So here, my use case actually defines that I should limit the hallucination and creativity of the model, so I cannot loosen this parameter. Just want to share with you this point. About maximum token, however you change it, the result does not change very much because like the Llama 3 8B instruct model I use, it will more or less stop at 500, 600 tokens every time. Okay, so the output window is quite limited. I mean, we can explore how to expand the output range, but at this moment, after multiple trials, this is 600, 700 is the maximum token size I can get from the response. So in the end, if you want to try different maximum token threshold, you can try it. But as my experience, there is a limit. Okay, with interaction with LM Studio and the local models. So the next function here is to save the record, okay, to HTML file. I really find this kind of function very useful, and the format you can define it very easily, and GPT can actually produce very high quality code to make sure that the HTML report you see is well organized. And you can see also here we can quote our queries, answers with line breaks, and so on. So eventually you are going to see the HTML file very well organized, so you can utilize it to view your results. In addition, I also save a HTML file of the save debug info. The reason I want to see this one is that I want to see the flow of the whole Python file, the whole program. Um, because from there I can check, for example, if some steps has some problem. For example, if the chunks of the text is empty or the vector store is empty, I can better debug. Of course, for professional debugging or the traditional way of debugging the softwares of the code, I think you can find many useful resources. But at this moment, I find this quite useful, so I use it to save the debug info. Okay, so you can see the different variable in each step. Like this one is about the text chunks. This one is about vector store. Later I'm going to show you. And in the end, here is the execution sequence. So basically, you can see we first of all we load the CSV file, then we convert CSV to text, then we split the documentation to chunks. Okay, and we actually have two operations. First of all is text chunks, is the raw PDF document to text chunks. The other is the dataset, TXT version of the dataset split in chunks. Then we get the vector store one for the text documentation or the PDF. The vector store 2 will aims to store the vectors of the data text chunks. Okay. I know I repeat some of the wordings here. Maybe I can make this function and display more neat. You are free to modify it. I just make such a separation to make sure that I understand the flow better. In the end, there is a user inquiry. The user inquiry you can always modify. I'm saying I am an IT company and want to mitigate the GDPR risk. What should I do? What are the penalties for non-compliance with GDPR? Use plain non-legal tone. Do you have some examples? I also ask. Provide a comprehensive report. Okay, so this is my user query. And when we want to generate the final answer, we actually use the generator response function to put our user query with a vector store 1, vector store 2. So as you see the function above, it will interact inside, get a more comprehensive prompt to feed to the local LLM, large language model. And there we're going to print the final answer and also save the different information to the report HTML and the debug HTML. Okay, so that's it. The program finishes here, and let's come back to the left-hand side. You can always check there are different. This is a summary, okay, and let's check again about the main execution. Okay, the main execution is about the different steps. Okay, I really recommend you, whenever you finish this workflow, just ask a GPT or ask a large language model to organize the code, explain the code, get a summary of the sequence. So this one is not actually generated by GPT-4. It was generated by Hugging Chat using Llama 3 model. I think it's a Llama 3 8B. So I can have a better idea because after all these complicated functions, workflows. In the end, sometimes you forget. Okay. And the general workflow here is a more summarized, more high-level workflow. Okay. So basically, I think just to put it in a nutshell, we load the data, we set up a vector store, we define user query, we generate a response based on the above resources and prompts, and we save the query and response to HTML and debug to HTML. Okay. And following up, you can see here I make some notes about version 4. Some of the major debug actions I did. First of all, I solved the tensor issue with converting data frame to TXT. Because like I said, when you feed the data frame to the vectorization process and so on, maybe you'll meet a problem. It's safer to transfer the data frame to text information. I did additional data cleaning. For example, like when the data frame actually had the non-available value, in some functions, sometimes it will generate error code, and incorporate the text doc handling. So basically, it's related to the data frame to text and the text to text chunks and to vectorization. And the last one is change the data input as text input. Okay, so text chunk 1. So basically, I did multiple debug actions to actually make it work, as you see. This kind of description is quite summarized and with a few words. If it's not clear, you can refer to the key point page. I'm going to scroll down again, and in the end. So if you have any question about any point, just feel free to ask me. My suggestion is that to keep your record registered, because in the next step you can come back and see how the journey goes. Okay, you build up this program to go through the whole workflow to generate better prompts and ask the local large language model. And in different version, you did something which could be very useful for your future projects. Okay, and let's come back. There is one last general comment that was generated by GPT-4. Let's read it. The code extracts and processes textual data from documents and structured data from CSV files. It uses embeddings to determine the relevance of stored documents to a user prompt. It then combines these relevant documents with the prompt to query a large language model, generating a comprehensive response. So let's go back to the beginning. I ask GPT to use LangChain framework to actually help me improve the performance of large language model. Okay, my objective was to generate a report, a GDPR risk is like a risk assessment report. Okay, suggestion report based on the dataset I gave, based on the law I gave, and ask a LLM to wrap them up all together. And then regarding the database management, it also gave the comment like, okay, we are not interacting with SQL, non-SQL database. I mean, if you want to make it a higher level interaction, of course, you need to have such a database to actually make sure the large language model to interact with such especially private data in your local environment. About vector store as a simple data repository, yes, it acts like a rudimentary in-memory storage system. This is quite important because it actually transfers the text information into this embeddings store, vector store, so you can query very efficiently. And about data loading and some of the techniques that we manage the data, of course, it also made some comments. Yeah, so remember, here it only mentioned about the merging the data, and one more important point is that the data should be converted to text. At least for my example, I think it works in this way. Then, if the application requires more sophisticated data handling and the persistent storage, okay, you need to have a proper database. Okay, is like the point number one, and you also need to have further considerations. Okay, this is just a quick go over of this project. Then let's quickly check some of the results. You can see this is the HTML file result. Left hand is debugging report. Right hand is GDPR compliance inquiry. And this report you can change the name as much as you want. So let's go through the debugging report first. So basically, we combine the data frame that we get. Is about the sanction historical data, how much fine was the GDPR authority actually sets to the different company. Okay, but you see the format. Okay, like the second table, actually the format is different because we have different column title, so it actually moves to the right. Okay. Then in the following part, we can see the first few sentences from the PDF, first few documents stored, okay, and the first four documents stored for the dataset. As you see, the dataset is also transformed to the text format. Then we can see the first few embeddings. Okay, it's all numerical vectorized data, and it's quite long. If you see, this is just the first few. I think first five, yeah, if I remember correctly. Yeah, this is also the first few embeddings. I think this part is about the data frame, and in the later part, we can see here is our query. Okay, as you see, the query was in the code, but this part I only showed the user query, but in the actual running of the program, the query is more complicated. Okay, it's not only about this part of the query, it's about the query including the embedding search of the existing knowledge base and also your query. Okay, so we can see in the end, we can see the generated response. I think it's quite comprehensive at this moment. Okay, you see that fines can be severe, and it actually quotes the both the clause of the law and also some of the information I think from its knowledge base. And what should you do? Okay, this one, conduct a data protection impact assessment. This one, because according to my work experience, I understand there is such an assessment, so it's pretty accurate. And about a different suggestion, I think they all make sense. It's not 100% comprehensive, but I think it's a really good start point. And then it quoted some of the historical data of the fines. But here I doubt it actually used the data frame I gave, because I think the Llama model was trained actually before 2023 the data, or the beginning of 2024. So basically, most of the data I get are historical data, so which matches its training data. So here, I'm not 100% sure it actually queried my knowledge base, but of course we can check the log to make sure of it. Okay, if we are not sure about the query, how the query was constructed. Then about the comprehensive report. Okay, so it actually gives several sections. Then comprehensive report is here. Okay, we did do data mapping, privacy impact assessment, implement the security measures, training employee. Okay, it actually repeats a little bit from the previous section. Of course, we can further adjust our prompt or the penalty score to get a better result. Okay, really pay attention to the penalty score, because when I did not set it, I get a very long and very useless information. Additional tips, additional tips are also informative, Yeah, that's it. And you see here, we still have some of the not very good parts about the. I think it's like the repetitive nonsense characters. Um, for at this moment, I do not have a solution to it, but of course we can try to give some more clear prompt, structured prompt, even prompt templates to actually confine our outputs in further step. So I think is okay. Then on the right hand side, you can see this is a much better structured compliance report. Okay, this is my query, and this is the response. Okay, the same as the left hand side. But on the right hand side, it looks like a very good and well structured report. Okay. Um, One more thing I would like to share with you is that whenever you come back to the to see the test record I gave, you can check there are different versions of the debug report, GDPR compliance report. So basically, every step I improve some of the coding or improve some of the strategy. I actually build the different building blocks of the program. And when I realized some of the variables were not fitted into the different function, actually that was almost the last 2 or 3 versions. So basically, for the first four, I think first four versions, I did not actually include the vector store of the data frame. Yeah. So this is just a reminder to you that whenever you build this kind of program, really pay attention to see if all the functions are called properly, and to make sure that your answer is at least including all your current assumptions and resources. One more thing I want to share is that if you are asking large language model to give you, for example, like this search embedding part, okay, so at the first it gave a naive strategy, okay, so I realized it only after I implement the, the the code several times. Then I realized it's called naive search in the beginning. So naive search is just to give you the top five chunks without actually running any similarity algorithm. So when I notice that, I ask again. So actually, GPT suggests me to do the suggestion to do the similarity check. I think is a cosine similarity. Okay, just to compare your query with the vector store. Okay, the document. So document embeddings. So in this way, it does not only show you the first top five of the according to sequence. Now it shows you the top five search results based on the cosine similarity calculation. Okay, so this is another point I want to share with you. The reason I want to share with you in the end, because I think this one is actually going to determine if your prompt enhancing strategy is working or not. Because at first, I only used the naive query, so the response change was not very obvious. There are also some other documents I want to share with you. For example, like when I did the two versions, okay, the pure LM Studio query on the left and the structured query on the right. At this moment, it was only combining my query with the naive search of the legal document. Every time I compare these two results, okay, I see which one makes more sense. It's like your local prompt arena. You can compare them. And even in the naive search phase, you can see that the right hand side result is that does make more sense and can be more comprehensive. But you can run multiple tests. And of course, based on your different HTML, you can feed it to GPT or other large language model interface where you can upload the document, okay, to ask it for ranking. It is very interesting, actually. You see, GPT actually ranked the LM Studio response. This one is a very basic query result. Actually, give it a very high grade. But then you see the following one, two, three, four, all are the versions with the more reached prompt. Okay, where I have the query merged with part of the information that I provide, which I call it a local database. Okay, so you can also try this to grade the results. But again, however, it grades the result. The user is you. The use case is based on your use case scenario. Always check to make sure that this output is matching your expectation. Here, as a final display, I would like to share with you the latest two running results of my code. So basically, this is the ML Studio server, first of all. Um, and on the left-hand side is the first time I run this code. On the right-hand side is the second time. So you can see here with um, all the functions, all the functionalities of my program. Now I can actually enrich my prompt with a lot of data. First of all, um, about the data set I provided to the system, so it can actually refer to that data set. Okay, so you can see this is the content of the user. Okay, the system message is always the same. You are a professional GDPR advisor, specialized in GDPR compliance analysis, plan drafting, report generation. Okay, and here we can see the prompt like violation of different GDPR rules and different fines of different company. So I think the system is actually retrieving from the vector base this information. Okay, so the retrieval of this information, I would say, is successful. Uh, on the right hand side, there is not much change because I think the similarity of the vector store and my original user query remain the same because I use the cosine similarity. So basically, the engineered prompts are similar. They are all fed to the system to get a response. Okay. Uh, Previously, as I mentioned, I only included the law part. Okay, the legislative uh, PDF, and the system is fetching its vector space, vector store, and get the relevant information. However, after introducing also the dataset txt, we can see, of course, the information is more abundant, but we are not sure about the results. And very interesting is that now I think the system recognize less about uh, the PDF part. Okay, as you can see here, almost everything is about the past um, violations of different company. Okay, so I guess from a similarity point of view, the system now or our program is recognizing the similarity more on the data frame and not the law part. Now let's skip to the final compliance report. So both versions, I think, show a good template. I think for us to understand the how do we mitigate the GDPR risk for an IT company. Although you see there are some small differences because each time you prompt to the LLM, it can generate different type of answer. Um, then let's go down. Um, about the end of the report, you see the problem shows again. So basically, before this version, I actually, like I said, I tried to limit uh, the presence penalty and the frequency penalty. it worked. Okay, but however, when you restart the program, sometimes it does not work again. So after these two attempts, I actually did one last try just a few minutes ago. And this version, I limit the token size to 1,000. Previously, it was 3,000. After limiting the token size, okay, the debug report is the same because our PDF text information, our data frame text information does not change. And let's see the final result is better, okay, but you still see here, okay, it was trying to generate some examples, okay, but it stopped because we have a limit of the token size. So in here you see there is no repetition, and of course the answer is structured in another way. You can see here. What should you do? Data protection by design, transparency and communication, data protection principles. Okay, it's like uh, and I think this is more structured, like the legislative structure. Okay, but let's check this log because I just run it. I think we can open the log and see. So basically, whenever you open the log in LM Studio, you can see here. Okay, this is a prompt. Actually, after incorporating our database and the law, this goes to the system. You can see here, most of the information is about the past violation of the law, the records about the fine amount, and also the company name and so on. Still focusing on the data set. And because I have one of the CSV you saw, actually it get only 5 records. Okay, actually for that document, I think almost everything was cited. Okay, in this way, I suppose some of these characters, for example, this is the URL link. Okay, it's very complicated. It does not mean anything. But when we pass such type of information to the large language model, I do not think it will improve our results. Maybe create some confusion and so on. So anyway, in the last version, I think I just showed you the way to actually limit the error in the end of the answer by adjusting the token size. As I said, you can try multiple times. Okay, and also maybe also try the prompt template to actually get a better result. Okay, so just a wrap up of this project. First of all, I tried to ask GPT to incorporate the LangChain documentation with my project idea. It gave me alternative, so I have to refer to a different source, okay, to process the local information I have. Okay. Also, it was downloaded from the Genius package and also Wikipedia and also the GDPR website. Okay, it can be considered as external, but I save them as local, so I refer them as local. So I have this local data source that I incorporate with my query. Okay, so I get a final prompt. Okay, the chosen text message is based on the similarity to my user query, and I put them all together and prompt to the system and to get a final answer. So as far as I know, LangChain is utilized in more complicated scenario, but from what the GPT suggested me, I think from this project, I actually have some idea of building some simple project similar to this one. But the choosing of the the embedding, vectorization, different method, I should be more careful and choose the best one for my use case. And I think there may be additional variations from this project I'm going to try in the future. For example, if I want to be an expert in interpreting the accounting regulations or accounting rules of a specific country like Spain, I might get all the official documentations, most of them PDFs, okay, and save it locally. And I can also get some accounting ledger example from the website, from different website, different open source information. Put them together to improve my prompt or to make it incorporate in the chain in the future. In my example, I only improved my prompt, but I do not yet incorporate the chain. But I think after this project, the basic idea I already get. Okay, I wish this could be useful for you. You may check all the example HTML, different Python program files. And if you have any suggestion or any doubt, feel free to let me know. So I wish it could be useful for you. This video is a little bit long, but I just try to go through every detail, every trial, every test as much as I can. So wish you good luck building your program and see you next time. Bye bye.